Hi there, this is 𝗥𝗘𝗦𝗧𝗏 Algebra Lessons. This is Unit 8, Lesson 4 on ellipses. So, ellipses, if you remember from Unit 1, we talked about what they were a little bit. They, instead of a perfect circle, well, that's not a perfect circle, but whatever. Instead of a perfect circle, they look more like ovals because of the foci that they have. And they also, they have coefficients that are different. So that's why they can look like that. So let's look at some terminology. There's some things that we'll need to find and look at. There's a major axis. This is just a longer axis. And by axis, I mean if we have an ellipse like this, for example, here's the major axis because it's the longer one, and here's the minor axis because it's shorter. So there's major and minor axes, I guess that's how you would say it. And then it is a values away from the center point. We'll see what a is because we'll have the equation down here. And because we have an a and b, and that it is a values away from the center point. Now sometimes people make a and b able to be switched, but for this purpose we will say that a is always greater than b, because it's kind of gets confusing, but if you just make it in that way, then it seems simpler. So the minor axis is the shorter one, and it is b values away from the center point. And then there's foci. That is just basically a point that defines an ellipse, and it's not very easy to explain mathematically because that's not what our purpose is. But when you need to find them, you use the equation that kind of looks like the Pythagorean theorem, which really that c there could be a f. But it's not the same because it's not a squared plus b squared equals c squared. It's a squared minus b squared equals c squared. And c is the focus. Okay, then there's rules. If you see that x is divided by a and y is divided by b, in other words, if a is always greater than b, if the greater number is under the x, then the ellipse is horizontal. If the greater number is under the y, then it is vertical. And then points negative, sorry, got something stuck in my throat. That is the center of the ellipse, and 2a is the length of the major axis, 2b is the length of the minor axis. And then you have to find vertices and co-vertices, which are just the things like if you have an ellipse, there, like the kind of corners, and the vertices are the ones that are on the major axis, which are points a0, negative a0. If there's transformations, that changes. And then co-vertices, oh, that's actually incorrect right there. It's 0b, 0, negative b. That's what it's supposed to be, sorry. That's the co-vertices. And so that's what it is. So, well, that will make more sense in a second. So we have kind of two equations. They're pretty much the same thing, but just a and b switch. And I'm not going to read that out, but you can see how that is. It's like the circle, but instead you divide by a and b. But like I said, if x is divided by a, then it's a horizontal ellipse. And a horizontal ellipse looks like this. Kind of like, imagine a lemon or something, or a breadstick or something, I don't know. Then if y is divided by a, then it's a vertical ellipse. So it kind of looks like an egg, I guess, if that's what you want to call it. And we had a y equals form for the circle so that you could plot into the calculator, but I actually found out a way that you can graph any conic, and you don't have to do that crazy thing that I showed you in the lesson 2. So sorry about that to waste your time, but there's actually a conics button that I'll talk about in lesson 6, which that should be in the description, but if not, just look up lesson 6. And if the ellipse is not in the above form, just like in the last lesson how we learned how to convert to from the standard form, you need to do the same thing that we did in the last one. That you just do the same thing. So see the last lesson if you want to remember that. So we have, what do we have? 2 things? Okay, try to hurry this up. To complete the square, oh yeah, I already said that. In the last lesson, you need to make sure that A, in that case, would be 1, and then you add that to both sides. But for number 1, we don't need to even convert, but we need to find some things so that we can graph. Let's find our center point first. So whatever the center point is tells you what transformations you will add to the points that you find out to be the vertices. But I said that whatever H and K are is what the vertices are. But if you see there's nothing there, that means it's 0. So that means 0, 0. K and H are both 0. So the point is 0, 0. And whenever it is like that, that's a lot easier. So be glad it's like that. Then let's figure out what A is and B is. A is going to be, well, we said that the greater number is A, 25 is greater, and since it's under the X, we are going to have a horizontal ellipse. So at least we know that. That's kind of what it will look like. A is not 25, though. It is 5, because we said that it's A squared. So if A squared is 25, then just A is 5. B would be 3, because B squared is 9, so that means B is 3. Okay, now if we want to find the foci, we will use this form, or sorry, that's not right. A squared minus B squared. A squared would be 25, B squared would be 9. So you really just do the things that were right there. And then 25 minus 9, that would give you 16. Oh, yay, good. 16. Because that means we get our foci as 4. Well, C would be 4, so actually that would mean our foci would be 4, 0, negative 4, 0. So how do we know that that's what it is? You always have a positive and negative for the foci. And how do you know if you'll have a 0 here. You'll either have a 0 in the X or Y slot, and the 0 goes in the place where the smaller number is. So since the smaller number is under the Y, we put the zeros where the Y's are, and then we put the number we found in the X slots. Except if you did have transformations here, then you would still have to add that to the foci. Okay, so now we know that. We actually can find our vertices now. I'll just have to figure out where to write that. I'll just say V for vertices. So the vertices are the ones that are on the major axis, and that would be our 5. And since that's in the X place, 5, 0, negative 5, 0. We always have a positive and a negative. And then our co-vertices, I'll just say CV, would be 0, 3, 0, negative 3. Now we can graph. So we have a center point at 0, 0. Then we need to go 5 left and right. So that would be here, here, then 3 up and down, 1, 2, 3, 1, 2, 3, and since it goes wider than it does up, that's what makes it an ellipse, and that's also what makes it a horizontal ellipse. So that's what our ellipse would look like, and just to say, our foci would be here. And really, it kind of makes sense, because if we had A and B as 3 and 5, we would have 4 as our C because of the 3, 4, 5 triangle rule, but you don't really need to know that in this case, but that is something that there is. Sorry that there's a cursor right there. I actually screenshotted this, because I made this lesson originally, and it was messed up. Okay, now we have this one to do. We need to oh, this time we're going to need to complete the square and all that. And we need to first we need to group our terms. So make the x's together. 9x squared minus 54y, or sorry, x, plus, then we have 4y squared minus 8y. Then we have that minus 59. We need to make that on the other side as positive 59 by adding it. But I said a has to be 1, and our a is 9 and 4, so we need to divide that out. 9, 4. So then we would have our 9 on the side, x squared minus 6x. We'll leave a space there. Well, we can do 6 divided by 2, 3. 3 squared, 9. Okay. Then we divide out the 4 there. We have y squared minus 2y. 2 divided by 2, 1. 1 squared, 1. Equals 59. Now we need to add things to 59. That would be our 9 and 1, but be careful, because we divided out a 9 and 4, we actually have to multiply that. So we need to do 9 times 9. You need to add 81. 4 times 1. Add 4. So we have 59 plus 81. 59 plus 81 plus 4. That's 144. That's the number we like to see, because that is perfect square. Now we need to make this into our form like this. And because that would turn into that by our rule that we've already looked at with factoring, so I'm not going to explain it. Then we would have our y minus 1 squared equals 144. And for this case, we actually need over here that to be 1. So we need to divide by divide by 144 so that that can be 1. Forgot to say that above. So once you do that, you then have this. And then equals 1. So this is the answer for that. Now, technically, I was gonna graph that, but you saw how the process was above. Same thing applies here. So I'm not gonna do that just for time's sake. I don't know if I mentioned that in this video. I can't even remember, or if it was in the last video, but I have. It's very hot where I am because I'm in a car. Might just turn it on. But, and I have to do something, a meeting at 9:25, and if you see up there, 9:09. So that will be it for this video, and I'll see you on the next one on hyperbolas.